Hi there. In this video, we'll be covering a very interesting problem. This problem involves a force that drags a mass at an angle, and there is friction on the surface. And the problem is written here for you. A block of mass m is pulled along a horizontal surface. So let's draw the mass. And this is pulled along a horizontal surface by a force at an angle of theta to the horizontal. All right, maybe we can draw this horizontal a little better. So this angle with the horizontal is theta. And it says the block travels with uniform velocity and has a displacement of d. And the coefficient of friction is mu. So let's see what the forces on this block are. So we have the force applying a normal reaction, the earth pulling this mass down by its weight, mg. We have friction, and of course we have this force, capital F. And this is going at a horizontal velocity, which means there is no acceleration. And hence there must be a complete balance of forces. And of course it is moving on the floor. It's not moving up or down. Hence there should be a balance of forces in the vertical and the horizontal direction. So first let's find out what is the balance of forces in the vertical direction. So in the vertical direction, we have the vertical component of this force, which would be F sine theta. Then we have the normal reaction N, and then we have mg. Equating and creating a balance of these forces would give us N plus F sine theta equals mg. So with this, we'll be able to get the value of the normal reaction. Now let's focus on the horizontal forces. On the horizontal side, we have the horizontal component of this force, F cosine theta, and friction on the other side. And F cosine theta minus F equals 0. And we know F is nothing but mu times N. Mu is given in the problem. So we have F cosine theta equals mu times N. From this equation, maybe we can call it equation 1, we can replace the value of N here. F cosine theta equals mu times mg minus F sine theta. And I can bring all the terms with this capital F onto the left-hand side. F cosine theta plus mu F times sine theta equals mu mg. And this will give me a value of mu mg upon cosine theta plus mu sine theta for F. Now we need to find out the work done as this force has moved the mass to a displacement of d. And the work done is essentially given by F vector dot displacement vector. Now it says it has a displacement d along the horizontal, which means the displacement can be written as di cap. And the force F vector can be written as F cosine theta I cap plus F sine theta j cap. Now I'm going to take a dot product of these two, F cosine theta I cap plus F sine theta j cap with the d I cap vector. And what I'm going to get is only the I cap terms because there's no j cap term on the displacement side. So I'm going to get F cosine theta times d, which is going back to this expression for force that we derived, mu mg upon cosine theta plus mu sine theta times cosine theta times d. And this is the work done. And this is given to us in option B. And hence, we found the answer to be option B. All right, that was lovely. If you want to see more such problems, you can subscribe to our test series, which is on our app. And if you want to see some of our videos with interactive simulations, please subscribe to the Unnati Academy YouTube channel. My name is Shakti. I have done my BTech in electrical engineering from IIT Madras. My passion is teaching physics and math. And here's me signing off, and see you soon in another video.